In this lesson, we are going to learn how to generate realistic text using machine learning. So how exactly does machine learning actually generate text? Certainly it's not magic. The idea is to create a model that will predict the next word and then use the prediction to sample and thus generate text. So if your model predicts the 10 most likely words to continue the sentence you've started, then you can sample those according to its probabilities and continue the sentence. There are many approaches to doing so, ranging from very simple to more sophisticated deep learning based approaches. With simplicity, ease, and speed in mind, we're going to discuss Markov chains. One of the best ways I found of thinking about Markov chains is the following mental model. You think of it sort of as a board game where your piece is some location and then you throw some dice and those determine where you go. So all that matters is where you are and what the dice show. Except when we use Markov chains for text, the location is the current word or last few words and the dice can be biased. More formally, Markov chains are probabilistic models where you calculate the frequencies of transitions between different words or characters and then use these to transition. You basically sample based on the frequencies. So to give you an example, let's say that our text is this sequence of characters AA, BB, AA, C, and we pick some order for a Markov chain, so I'll say order 2, and then we're going to list all the transitions. So given that you're an AA, we see a transition to AB, and then from AB you transition to BB, from BB transition to BA, and then to AA, and then AC. So those are the order 2 transitions. Order 2 because we look at 2 characters at a time. Now we calculate the frequencies. So let's say that you're at AA. Well, half of the time you go to AB and half of the time you went to AC. So those are the frequencies. Now let's say you're trying to generate text using this Markov chain and the last state that you're in, the last characters that you see in your sentence are AA. Then to generate the next characters, you will look at your table of frequencies, which is 1/2, 1/2. And you'll see the probability 1/2 you should go to AB, probability 1/2 you go to AC. So you toss a coin, one side represents AB, one represents AC, and then that determines how you generate the next characters. And this way you are able to generate a bunch of text. In this lesson, we are going to generate text using machine learning. First step will be to import Markovify library. This library offers a number of useful Markov chain methods, such as how to build one, using text that you feed in, and also how to generate text from this Markov chain. I'm going to read in some text into a variable. In this case, I've chosen the Declaration of Independence. Next, I'm going to create a Markov model off of this text. Behind the scenes, the Markovify library is computing a frequency table. It's looking at frequency, just as an illustration, the word states after the word united, which is almost certainly 100%. It's looking at the frequency of the word to after appealing, which might be 60%, and so on. And it's constructing a transition probability table, which is then being used by the Markov chain when you want to generate something. So now I'm going to generate some sentences, and now it's going to take this table which we have generated and sample from it to create realistic looking sentences. We can also specify the length of the sentences. So in this case, I've chosen 140 characters max, which you might recognize as a limit coming from Twitter. We'll be making usage of this when we create a Twitter phishing bot.